they would like to create. And I think I'll be back here. And so what I show you is like a first version of this browser. And with this browser, we conducted a study, and that study is the focus of the paper. I'm not sure what happened. This cable touched my laptop, and then everything died. But I'm almost back. I'm almost there. So, by the way, the other thing I wanted to say, this is a multi-device environment, right? And all of you guys are here with multiple devices, and it would have been so great if some of this research would be at the stage where we can just flexibly, I could just borrow some of your devices to help me out in this kind of situation in which I was just in. So let's skip this a little bit because I'm going to skip 2 slides, but that's fine because Peggy covered it all. And so what I wanted to say is basically I wanted to think about how we actually currently program interfaces. And the way we do it right now is we have this really growing device landscape, and it's really difficult for designers to create all kinds of interfaces for all kinds of these devices. So what happens in practice right now is they create different versions of interfaces that run, that adapt very well to these devices individually. But now, in addition to the multi-device interaction things, and Peggy has shown us some cross-device interfaces, but I'm really thinking about these interfaces that can run across multiple devices, that can span across these devices arbitrarily, that can involve multiple users, and definitely also multiple devices of different sizes. And so the motivation why we want to do this is basically cross-device interfaces can be useful for many things, especially in mobile scenarios where it is now possible to combine multiple smaller devices to create larger screen real estate. It's also possible to actually, not in every situation it makes sense to provide voice input to your smartwatch, but smartwatch is technically, at this stage, usually bound to a smartphone, so the smartphone could easily become an input device to the smartwatch, like a keyboard for the smartwatch. And then what you've seen, and what you see in many projects, if you look into the papers, is really this idea of remote control, where you use a smartphone to actually control larger screens. And so over the years, I've built these like family of tools, this XD family of tools, where Peggy mentioned XD Studio before, but I've actually tried out other kinds of directions of really creating cross-device interfaces, and that's just me. The community has, of course, investigated a wide variety, so don't be mad at me if I didn't include your paper here. Thank you for showing up. There's a lot of work, and I couldn't cover it all, but more recently I think we've seen this direction going towards smartwatches. And so what I want to show you today is basically XDBrowser. XDBrowser is a browser that itself is aware of multiple devices that the user may be carrying. XDBrowser is a distributed user interface in itself, and what you see here is that each of these browser instances, if you will, have awareness of the other kinds of browser instances that are running on other devices as expressed by the color coding here. And yes, I know color coding is not ideal, but that's what we do right now. And so what XDBrowser now allows us to do, if you are a web designer in the audience here, clearly the title is, I want to show you some cross-device web page designs. So you're very much thinking about responsive design at this stage, making sure that the web interface looks very well individually on each of these devices. And maybe some of you, I don't see this yet, we don't have the web browser on smartwatches, there's only one at this stage, but some of you will soon have to think about how we can actually adapt our web interface or parts of it to run on smartphones. Now the idea of XDBrowser is maybe you don't have to think so hard about it, because what I want to do is raise all of the things that you've seen previously in cross-device toolkits, the technical support for cross-device interfaces. I want to raise it to the level of the web browser where end users can do this. And so then end users can create such interfaces where they flexibly redistribute components of an interface as they see fit. And so I show you some examples of what people wanted to do with the browser when we actually gave it to them. And so this is XDBrowser in action, and here what I'm showing you is some examples. So this is Gmail distributed over 2 devices. This is Maps distributed over a tablet and a Microsoft Surface tabletop. What you notice is here is the same location, but in different kinds of information that you see. And one of the typical examples, and something that would have maybe saved my hand just now, is a smartphone that I could have taken out of my pocket to give this presentation to you by just hijacking the device behind me. Okay, so this is XDBrowser, and what I want to show you is quickly how users in our study, or the current state of the browser, how users actually created a cross-device interface like this. I don't show you all the things. The scenario here is that the browser can flexibly switch, the user can flexibly switch between different applications running on the smartphone and the tablet via tab switching on the smartwatch, as you see on the left. But the main application, and what I want to show you, is how we could, for example, distribute Gmail so that it makes sense. You can quickly check the inbox and then actually reply to to emails and use the larger device as a keyboard kind of thing. So what the user can do at this stage is, independent of how this web interface was programmed, no programming knowledge required, just select things with your thumb and move components around. If you will, it's like paper prototyping, but using interactive technologies. This web interface is, of course, created as a DOM kind of tree, so there's a lot of nesting involved, but the user doesn't have to care. They don't have to select the right element. They just move things around. They can enable synchronization, and once this is done, as I point out here, you can now actually interact. I'm not sure which hand to use, but you can now interact with this device. And the user now switched between emails that may have come in and can use the larger device for actually reading these emails and then answering to them. This is just one of the examples. Users have created many. We've also looked into a variety of interfaces. What I wanted to do here is actually choose popular interfaces. I claim these are end users of these kinds of interfaces. And what these interfaces resemble is something like Gmail, YouTube, Google Maps, and then the article interface here is something close to Wikipedia, if you will, and slides maybe something like Flickr or something that is more image-oriented. And so what we did was a study, and that's the core focus of the paper in some sense, with 50 non-technical end users. And they created 144, and now this is the key point, desirable multi-device interfaces, not those that are just technically feasible, because that's what we've seen a lot in the literature so far. Everybody proposes a toolkit, including myself, then I show you what is technically feasible with this, and we are all impressed. But is this really what users want? And so I wanted to explore this a little bit more. What I noticed in the study is for each of these 5 interfaces, on average, people created 2 different versions. And this was because in mail itself, you do multiple tasks. There's not just a mail task. You do multiple things in mail. One is like checking from mail and maybe replying to it. And others, a very intensive task is actually composing an email. And so we have now, based on these 144 cross-device designs that were created by users, we analyzed them, and we extracted 6 cross-device interface patterns. Some of these patterns are pretty clear, so I chose 2, which I wanted to show to you in detail. There are more in the paper. Interesting was to observe how users created these interfaces. So they used primarily 3 strategies. Clearly, they wanted to optimize for screen space, and what I mean by this, often you want to combine screens to create larger screen real estate. You also want to optimize for input. This, we used mobile phone and tablet, as you can see here, and what this meant for most people is that they would use the tablet to actually provide input rather than a smartphone where they don't have such a big keyboard. And they also wanted to minimize this device switching. Clearly, we all know that there's attention division between multiple devices, and so you want to kind of, even though when you switch between tasks, it makes also sense. One of the results of the study was you want to trigger different kinds of interface depending on the task, but you still want to minimize device switching. So these are kinds of parameters, and in this space, these users try to create different interfaces. So the overview and detail pattern, for example, here applied to mail is the one that you saw earlier, where I'm cutting kind of like the inbox component, and the actual reading, the reading pane is then on another device. And this can make sense, for example, if you have multiple incoming mails that you want to read and reply to, or you're replying into one email, but you want to look up another email, and because there's some cross-referencing, and this can be very useful. So another pattern, so can I just say, so what is important about these patterns is what you see here is that the interface is really distributed. So this supports asynchronous tasks. What we see a lot with cross-device interfaces is a lot of mirroring is happening. And so what's the point, right? We don't need to have the same interface replicated on all kinds of devices. It can make sense in some settings, but not in this. So we saw more of these asynchronous use of multiple devices kinds of patterns. And the other one was really clearly assigning roles to different devices. So a popular one was to actually assign the role of providing input to the tablet. But as the user actually provides input on the tablet, you can write an email here, for example. This could also then feed back into the smartphone. And what I'm going to show you is I want to discuss some of these things, and then I want to tell you what I'm going to do next, because this study is like the first result of a larger project. So this is at the same time an end-user customization tool. So my point here is that we've seen lots of toolkits out there, and whenever I do studies on cross-device interfaces, I always get feedback from reviewers, which is valuable, but they always ask me to find these cross-device developers and do studies with them. And frankly, at this stage, I struggle because we don't have this generation of cross-device interface designers. Clearly, we have interface designers that care very much about interfaces adapting well to different kinds of devices, but not the kinds of cross-device experience studies. It's just difficult. And so my approach here was to study with end users, so we need to enable them, and a tool like XDBrowser can do this. Then what is important, and I think one of the main results is, even though we created now a tool that's relatively flexible, and we saw lots of different kinds of interfaces for five popular kinds of applications, it was really clear from the users from the user study that we need to be able to easily trigger and switch different patterns. Even while somebody is working within one application, it becomes even more interesting when they work across multiple applications. Users want to be able to reconfigure these cross-device interfaces. What this tells us is, even though this toolkit approach to cross-device interfaces is valuable, designers will probably never be able to fully anticipate all the kinds of devices, all the kinds of device configurations, and all the kinds of interfaces that users may want to have. So a tool like XDBrowser, which is an end-user customization tool, is very useful. At the same time, users wanted my browser to do more things more automatically. So even though I tried to make it very simple and move things around, just selecting and moving, they wanted things to be more automatic, and I myself want things to be more automatic because I don't want it to become an authoring kind of tool. It should still be a browsing tool. And they want more fine-grained control when it comes to synchronization. I discussed this. This is an interesting aspect specifically for people that create cross-device toolkits, and so this is extensively discussed in the paper. Where to go from here? So I wanted to show you two things that I'm currently interested in and will continue while I'm at Michigan. So where to go from here? The first thing is I'm creating currently XDBrowser 2.0. By default, it actually duplicates this. It's like a mirroring by default. But once the user decides to double tap into a component, something we're very familiar on mobile devices, to zoom into components, XDBrowser would automatically create this cross-device interface. It is basically an instantiation of one of the patterns that we've learned from the study. And the key challenge now becomes to extract the relevant web page DOM elements and trigger the right pattern. And this, the user here can choose whichever device and whichever order. And depending on the element that they double tap, like could be a video on YouTube, we would then apply the reasonably good cross-device pattern. And the other thing is, even though my work, most of it has been happening in browsers, the other work, the other direction that I'm following is really how does this apply more broadly. So this is going to be a bit confusing, but here you have like a smartwatch, smartphone setting. The user just replicated one of the screens to the smartwatch. Now the user starts to provide input on the smartphone, but then decides to actually provide speech input on the watch. And it can also be done the other way around, which is what I'm going to show next, is the user starts a task on the smartwatch, wants to provide input, but this is probably a longer subject, so they just use the phone as a keyboard. And if you found this video confusing, this is good, because I wanted to show you the flexibility that we can achieve by making this possible in a cross-device scenario. That's the point I wanted to make here. And so I think, I'm not sure how I'm doing in time, but sorry for the technical problems in the beginning. I'm happy to take your questions now. Okay, thank you.
James Egan, Telecom Paritech. Thank you very much for this talk. I really like this work. I did want to push back a little bit on the assertion, though, that it's desirable interfaces. Mm-hmm. It strikes me that these are more desirable partitions of existing interfaces. Mm-hmm. But for example, I was wondering if do you have a sense of how you would be able to, for example, prototype or model something like, say, shaking something on your watch, mm-hmm. or doing some sort of interaction that the underlying application doesn't already support?
Yeah. So two interesting things you're pointing out here. One is that the users didn't actually create new parts in these interfaces, so it was not a reauthoring of the interfaces introducing new elements. So this becomes very interesting in the cross-device use. So it is right. You could think of it more like as a reshuffling of the existing elements, which makes sense to some desired for these users given what they have. But the community out there has thought about how do we design a much better YouTube interface, and this is certainly a viable direction. What this tool gives you is you can transform existing interfaces and reconfigure them. The other thing is the whole interaction stuff, like coming up with new gestures that would fit in. XDBrowser at this stage is not designed for it, but it could be a browser, and there could be extensions to it, and who knows what's going to happen at WIST and Kai next year. And so we will see.
I look forward to seeing it.
Okay, thanks.
Hi, Mike. Hey, thanks for your talk. It's very nice to see it again. All right, Tao Dong from Google. So I have a question. I'm wondering if you think new interaction and interface techniques on small displays might make some of the cross-device patterns not necessary. So I feel the usability of small screen input and output are being improved every day. And I feel some of the patterns you have showed from the user's exercise of this distribution is kind of a response to the failures in designing UX on these smaller displays.
That's true, and so I don't want to be too negative, but I think some of the interactions would probably not make the patterns obsolete, but they would help us actually trigger these patterns in more natural ways, because what we've seen right now is this like selecting and moving around, and double tapping is still very constrained. So I don't think this is the solution. So also in addition to what, who was before, I just forgot who asked me a question before, but basically this is a new version, and I want to explore these new directions together with the community. I'm also going to release this, and I don't think this covers all the kinds of cross-device interfaces that we may want. And I'm looking forward to Michel's question.
Hi, Michel Baudouin-Lafont, Université Paris-Sud. Nice work. So, in the scenarios you showed, it seemed to me I don't want to say this in a negative way, but it seems static. And I don't know how people had to pair these devices together. Because in the course of a day, I have my phone, okay, it's my phone, but I have several tablets at home and at work, and several computers and maybe a TV and things like this. Yeah. So how do you see these patterns work in a dynamic environment?
Yeah, so so this is a study. We decided to have it more like a lab-ish study, even though, and so that's why we, for example, we didn't introduce new devices while we're doing the study. We just gave them these two devices. So related to your question is like, what if we add other kinds of devices or other types of devices? Do these patterns still apply? Is a valid question. I don't know. I would hope so. And then I think because it is a browser, and one thing I didn't tell you specifically is how it's implemented, what it does is basically it hijacks any kind of browser you have on your device. So this is not like the new Chrome or whatever. It's just using the browser you have on the device. So I think it's very flexible. It does require some more later HTML, CSS standards. I did have a little bit of trouble with smartwatches because there's only one open source browser out there called to Google. Maybe you should implement a watch kind of browser. So I'm not sure how this whole thing is playing out, but I want to enable people to use this browser more flexibly and in different kinds of environments. Yeah.
Can I have just a quick follow-up question? How do you see people, I might say, reify those customizations, and how do they persist? How do I, next time I come, do I find the email configuration the same if I have the same devices?
Yeah, so one thing is, and that has been done, is sort of kind of like a smart bookmark kind of way. So there's research on that when it comes to end user programming, and I think I could leverage some of these ideas. Now I think what would be ideal if I could deploy this kind of browser and really give it out to people, and lots of people can create different kinds of configurations, then we could actually build a community around it and maybe share it. What I would then share is like for popular interfaces, I think what would happen is popular interfaces and popular device configurations, new users coming in with similar devices could immediately benefit, and then we could also, would be a much more interesting study, I think, in terms of scale to do in the future. Yeah.
Thank you.
Hi, David Karger, MIT. So this is actually a very natural follow-on to the previous question, because you've started to identify these sort of common patterns of usage across the multiple devices and such. Have you thought about whether it might be possible to sort of enrich the HTML markup in a way that describes the page such that it can sort of automatically be partitioned appropriately across multiple devices?
Yeah, so this is, when I showed the quick video of XDBrowser 2.0, this is this current state that I have. So what I could give right now is like a toolkit to people that allows them, basically they could just annotate different elements, and based on these elements I could trigger these patterns automatically. So this is the stage that I have right now, but what I'm even more interested in is trying to be a little bit more intelligent about it by applying the techniques to existing web interfaces that don't follow any of these patterns. So what I would say is like this is the easy approach in some sense. May not be true for all kinds of websites out there, but I'm not sure whether this is really gonna be a vivid approach. So I think the more challenging and interesting research direction is actually to try to do some of this automatically based on the knowledge that I gathered from this study. Yeah.
Thank you very much.
Thank you again.